Hey, hi, students. Okay, so we'll wait for a minute and then start. Okay, so let's start the session. Hi everyone. Any questions on the assignment that we discussed in the last class? Some of you already sent me some questions by email. Apart from that, do you have any questions or any feedback? Okay. Um, so if not, then we'll start today's class. Okay. So before we start the class, one quick question, just revising previous concept. So we know that in an optimization problem, you need to first define the sets and then the input parameters, then the decision variables and objective function and constraints. So can we define the objective function before, after constraints, or does it necessarily need to be before? It does it necessarily need to be defined before the constraints? Anyone can answer? Yes. Hello.
So
Anyone?
I,
Mhm.
I think there can be a set of general constraints.
Mhm.
Uh, with respect to those general constraints, we can have then multiple objective functions. So once you fix an objective function, then you can also define more set of constraints which are pertaining to that particular objective function.
No, no. Forget about multi-objective. Let's simplify it. So let's say there is only one objective. So can we define objective before constraints or no? Okay. Yeah. So we can define objective function before or after constraints. The order doesn't matter. So there is no connection between them, but the variables have to be defined before the objective function and constraints. That is necessary. Yeah, and another thing I wanted to mention is, so obviously you're doing some courses in machine learning, I'm assuming. So there is a difference between the terminology variable in machine learning and variable in OR, because in machine learning, so let's say you are writing a function, z is a function of x and y, then there are only two variables, x and y. But in on the other hand, so irrespective of how many data points you have in the data set, so let's say your data set has 10,000 records, but you will you would still say that you have two variables, x and y. But in OR, if you have, the number of variables is equal to the number of data points that you have. So let's say you are trying to build an optimization model for, while you're trying to optimize the production of 10 products in a factory, which has, let's say, 100 machines. Then you will have 10 products into 100 machines, that is 1000 variables, and not two variables for product, one for product and one for machine. You'll have 1000 variables. So the terminology in of the not the terminology, but the meaning of variable in OR and is different from what it is in machine learning. Okay. Um, so let's start with today's class. So today, what we'll do is, in the last lecture, sorry, let me share my screen. The last lecture, there were some questions around um, inventory theory. Sorry, questions around supply chain. So today we'll go through some details about supply chain, manufacturing, and inventory. Today's class will not be so much formulation or maths based. It will be mainly understanding how these businesses work, some simple concepts in these industries, because these are the major one of some of the major industries where we apply OR, and so we'll go through that. I'm trying to share my screen. Okay, so let me know if you're able to see my screen. Yeah, are you're able to see my screen, right?
Yes, sir.
Yes, sir.
Yes.
Visible.
Okay. So this slide shows some of the key problems where we can apply OR in manufacturing domain. So, and again, in the slide, we'll look at in very briefly, and in the later slides, we'll go into a bit more details. And once you understand the concepts that we discuss in today's class, then later on we can discuss about how we can formulate these problems, because formulating supply chain problems is very helpful. So the first one of the major applications of OR is in manufacturing is inventory optimization. So we decide when to order, how much to order, what to order, determining what is the safety, what should be the optimal safety stock level and improved service level. Now, what is safety stock level, what is service level, we'll come to that. But again, from this when to order, how much to order, I think we already discussed that in the last class, that what are the drawbacks of ordering too much and drawbacks of ordering too less. So this is what this kind of optimization problem aims to solve. The next one is network optimization. So you might have some factories, let's say in different parts of India, and you have your customers in different parts of India. So how do you match your production and demand so that you are able to meet the demand in the promised lead time and with the minimum, by minimizing your supply chain cost, that is by minimizing your transportation cost, and improving your service level. The next one is facility layout planning. So how to optimize the facility layout based on material flow and cost, meaning within a factory itself, there are, for any kind of manufacturer, there are lots of, sometimes hundreds of processes. And how do you, so one product, so what you see, what you get in your hand physically is one product, but that needs to go through hundreds of processes sometimes and hundreds of machines, or multiple many machines. And how to, and the space in the factory is limited. So how would the factory need to, factory owner need to decide how to set up the machines one after the other, so that the traveling, and it sometimes it happens that a certain product would have traversed hundreds of miles within the factory itself, because there are so many processes and so many machines which are probably not situated optimally. So it needs to travel back and forth. So how do you optimize the facility layout? So there we consider information. We look at aspects like routing information. Sometimes material needs to be stored because the downstream machine might be busy. So there should be adequate storage space, and then equipment handling and packaging information. So this is one kind of problem where we use optimization. The other is production planning. So in a factory, you have limited people and limited headcount and limited machines, and your objective is always to maximize, not always, but in general, to maximize the demand. So how do you ensure that you can make, and those machines and people have always have a certain capacity, and the machines have a lot of other constraints like changeover, etc., which we'll see later. But how do you maximize the production within those constraints, which we refer to as plant, so plant meaning the factory, plant floor constraints. And how to improve the throughput and make the plants lean. So throughput is basically the amount of production that you are able to do within a specified time. And the next one is, once your material is finished good is produced, and how do you take care of the transportation in the optimal manner? So you need to decide how to dispatch your finished goods in different vehicles or trucks, so that you are able to meet the customer demand in the promised lead time, and you are able to do that at minimum cost. But then that you can do only if you're following if you're following an optimal route. And you should be also looking at, let's say if you can use one big truck or two small trucks, then which is better, because different trucks would have different costs based on their capacity and their volume. So this is another aspect in manufacturing. Okay, so now let's quickly look at how the infrastructure entire system of inventory management works. So any manufacturer would order raw materials and produce finished goods from these raw materials. But between raw materials and finished goods, there would sometimes be intermediate products. And once the finished goods are produced, they would be stored in the warehouse, and from there it would be shipped to different points of sale. It could be the wholesalers, distributors, retailers. There could be intermediate distribution centers and so on. So which are some of the industries which require or make use of inventory management? So manufacturing and FMCG. FMCG is, for example, Procter and Gamble or Unilever. These are FMCG companies. So the goods that they manufacture are very fast moving. Um, they are consumed on a regular basis by the end users. And then we have retail industry, e-commerce, and logistics. Now, out of this, the ones which I've highlighted in blue, they require only transportation, and the other ones, that is manufacture and FMCG, they require manufacturing as well as transportation. Okay. Now coming to discrete versus process manufacturing. So process manufacturing is any kind of product which is, once it is manufactured, you cannot break it down into further, into its constituent materials. For example, let's say medicine. Medicine is, or let's, yeah, medicine is manufactured from multiple raw materials, and once you manufacture a medicine, you cannot you cannot get back the raw materials from the medicine. While discrete is, manufacturing is, for example, cycle. So once you manufactured a cycle, you can still get back the raw materials. I mean the constituent parts, for example, the wheel, the tire, the handle, and so on. Um, so in discrete manufacturing, it's composed of parts that you can easily count, while in process manufacturing, it is there is a certain formula. So discrete manufacturing uses bill of material, which, and what's bill of material, will come to that in a later slide. While process manufacturing uses a formula recipe. Discrete manufacturing assembles in a linear routing way, while process manufacturing blends in a batch. Examples are automobiles, computers. For discrete manufacturing, for process manufacturing, it's drugs or food products. So this slide, I mean, this graph that you see on the bottom, this is, on the x-axis, we have the specificity to customer, that is how general these products are. While on the right axis, sorry, on the y-axis, you have need for product unit detail visibility. So if you see, if you move from if you move from left to right on the x-axis, you will see that first, we have the batch production. I mean, first we have the make to stock. That is where we, okay, now what is make to stock, make to order, what is engineer to order? We'll come to that later. But make to stock is, are goods again which are very fast moving. For example, any kind of consumer goods. So your toothpaste, your detergents, these are all consumer. These are all make to stock, because there will always be a demand, and the demand is, can be easily forecasted, because it doesn't have so much variability, because people will use detergent or toothpaste no matter what the market situation is. Now the next one is make to order. That is, make to order is you build those materials only when there is a requirement, or based on your demand. So particular brand of mobile phone, for example, could be make to order. That is, you make only when there is a demand. And at the topmost position in the pyramid is what we call as complex discrete manufacturing. So these are not made, I mean, these are made only when, these are manufactured only when the customer specifies the exact details. For example, medical devices, aircrafts, ships, these are not obviously produced in hundreds of units every day. These are produced in much smaller quantity, or let's say spaceship. And the end users are also very few in number, and they would be requiring only a very few units of this product, of these products every year. So they would specify how many units of the product are required, what is the exact customization they're looking for, and accordingly, the manufacturer would go ahead and manufacture these products. Okay. Any questions so far? Okay. So coming to types of inventory, so we have already seen what is raw material, what is finished goods, and the intermediates is work in progress, which is basically partially finished products or processed materials. So what are the objectives in inventory management? We need to prevent dead stock or perishability. So we need to ensure that the materials, finished goods, are sold before they perish. We need to optimize the storage cost because we will always have a certain limited storage, and we need to confine ourselves within that storage capacity. We need to maintain sufficient stocks that because if we run out of stock, then we lose out on revenue. Enhance cash flow, so we should not be putting in too much money to buy the material because and keep them in our factory, keep them lying unused in our factory for a long time, because then we have reduced our cash flow. Reducing purchase cost of goods, so again, this is linked with the inventory holding cost. So if you are buying only when it is required, that is good in a way. But again, the drawback is if you're buying multiple times, then there might be multiple shipments made, etc. So which might increase the purchasing cost. So the variable cost of purchase remains the same, but if your supplier is sending you the material multiple times, there might be some additional cost. For example, shipping cost. Okay. Now, pull and push inventory we already discussed last time in the last slide. So, push is when we produce according to forecasted demand, and this is very easy to do for fast-moving consumer goods. But the problem is, the drawback is there's a risk that we might be overstocking the product because we did not look at the exact demand. We look at the forecasted demand, and that might also lead to extra storage cost. And hence is less cost effective. While pull inventory is when we produce something only when it is required, only when there is a pull from the customer. That's why that we use the word pull. So this has a longer wait time because we start manufacturing only after the customer has placed the order, and that might lead to delay and customer dissatisfaction. Okay. Now, these are some of the costs of an inventory system. So one is the first one is procurement or production cost. Let's first come to the variable cost part. So whenever there is a production, there would always be a cost, which is a function of the quantity that you order or produce. So order is when you are getting from a supplier, and producing is when you're producing in your internal factory. And the advantage of this is if you are producing a large quantity, then the production cost might per unit might decrease. And similarly, if you are ordering a larger quantity from your supplier, then the supplier might offer some discount. Apart from that, there would also be a fixed cost. So whenever we need to do a fresh, in the case of production, that if we are doing a fresh production run, there is always a fixed cost of starting your machine, starting up your factory, and this is independent of number of units produced in the production run. So whether you're producing 1 unit or whether you're producing 10,000 units, this fixed you would be incurring this fixed cost. And for procurement, there is a fixed cost. There is also a fixed cost. So whenever you are placing placing an order, there might be some cost. And if your supplier is sending it, shipping it, then there might be a minimum freight transportation charge, which would be same whether you are buying 1 unit or whether you're buying 10,000 units. And also every time you get the product, you need to inspect and test that it is in good it is of the desirable quality. And again, this is independent of the number of units that you order from your supplier. Now coming to holding costs, so I think this is inventory holding cost, meaning inventory holding costs. So this is so the drawbacks, some of the drawbacks, well, we discussed in the last class. So if you have too much of inventory, then there would be storage cost, because you might be requiring AC to store the material, or there might be some maintenance cost. Also, there might be depreciation cost, because for perishable or semi-perishable items, we may not be able to sell the item if it's stored beyond its shelf life. Also, it reduces the cash flow because you have paid money in advance to the supplier if you're procuring from a supplier. And if you're producing in a factory, then if you produce too much in advance, then again, this money could have been better used elsewhere. And how much is the total inventory holding cost? That varies, that is directly proportional to the amount of inventory that you're holding and the duration that you're holding it for. So this is a general statistics which shows the percentage, how significantly high the inventory holding cost could be. So it is estimated that the inventory holding cost could go up to 25 to 55% of the inventory value, and this could be broken down into these categories: deterioration, cost of money, warehouse expense, obsolete, there's a risk of the product becoming obsolete. Okay, and why do businesses incur this extra holding cost? That is, why do companies buy too much? So sometimes they build inventory buffer because in case consumer demand spikes above the expected amount. Sometimes it might be due to seasonal demands. For example, in the US, snow shovel is a tool which you need to clear the ice in the winter season. So that they might have stored too much, or let's say in India, you might be they might retailers might be storing too much of jackets and sweaters during the winter season. Saving transportation costs. Sometimes when in companies order inventory in bulk, they do that in large quantities, because then the shipment cost reduces. This helps to save them money, but might this helps to save them shipment money, but it might leave them with more inventory than desired. Um, and outdated or unwanted inventory. Sometimes it happens that certain products just become obsolete, and we can deplete this inventory by offering discounts or price reductions. Now, what happens? So this is about inventory holding cost. That is what happens if you have too much inventory. Now, on the other hand, what happens if you have less inventory? So then you have what we call as a shortage cost or back order cost. Now, there are two scenarios here. So one is, if you don't have inventory at that point of time, then you can get inventory for the customer later on. And you can fulfill that customer demand later, either at one shot or continuously. In that case, the only cost is, there's a delay in delivering the goods to the customer, but you finally deliver it. And the other scenario is that you do not allow back ordering at all. So this is called back ordering, when you allow um, when you allow to fulfill the customer demand later on. But back ordering, if back ordering is there's another scenario where back ordering is not allowed. So in that case, the cost would be proportional to the shortage quantity, and if back ordering is allowed, then the cost is proportional to the shortage quantity and the time of delay. That is the time when the customer actually needed the item, and the time when we were able to deliver. So the difference between those two times. So that is what it would proportional to. And what does the this shortage cost or back order cost include? Consist of. So this would lead to cost of delayed. This would lead to delayed revenue, loss of revenue, and sometimes because we are giving the material late to the customer, we might offer some discount. So there again, you're losing some money. And the most important part is you might lose customers goodwill, because later on, when the customer needs that product in future, they might think that, oh, this company was not able to give me the product when I needed, but so they'll shift to the competitor. Okay, any questions, students? Okay. Um, so now let's go to some other important concepts. So one is what we call as safety stock. So these two concepts are quite interrelated: safety stock and reorder point. So safety stock is the X is the, can say, the buffer inventory that the manufacturer needs to retain to ensure that they are available to customers when suddenly demand spikes up, and it also acts as a buffer against unforeseen shortage in supply or variability in the lead time. Um, and what is reorder point? Reorder point is the level of inventory at which the company reorders or orders new inventory from the supplier to avoid the stock out. Um, so this replenishment of stocks considers factors like existing and potential demand and lead time before the new inventory arrives. And this reorder point is calculated by this formula. So now let's look at this graph. So in this graph, we have shown how the inventory fluctuates, not fluctuates, how the inventory varies with time. So on the on the x-axis you have time, and on the y-axis you have the inventory level. Now, if you see here, the inventory diminishes gradually with time, and I mean, first it diminishes here, then again it increases. So the reason is, so this point A is what we call as reorder point. So when the inventory falls below a certain level or reaches a certain level, we decide to order the next lot, so that by the time the inventory reduces from A to B, I will have the replenishment, and my inventory level will again shoot up to point B, that is the safety stock level, to point C. Again, my inventory starts depleting on from C to D, and again once it reaches D, once it reaches D, I decide to order from the supplier, and so that by the time, so the lead time is this time, that is the time between the x-axis between D and E, or here you can say the x-axis between A and B. So this point. So by the time it reaches the safety stock level, we will again get fresh stock, and my inventory level will go up. So the reorder quantity here is the distance on the y-axis between points C and B in this case. So this is what we refer to as reorder quantity. And economic order quantity is another concept. So here, so in reorder quantity, we always make sure that we have enough buffer inventory, but in economic order quantity, there's a formula for calculating that, but I'll not go into that. But it looks at both the it does not focus too much on keeping the safety stock, but it focuses more on minimizing the inventory stock. That is, we should not it looks at the inventory holding cost, the shortage cost, and takes both into account. So it takes both into account, while safety stock takes into account only how much buffer inventory we should be having. Okay, now coming to demand. uh, so demand can be both deterministic or stochastic. That is either, that is, and I think we discussed this in the last offline class, that for a certain product, you may be having the next 2 weeks of demand. You may be knowing the exact demand for next 2 weeks because the customers have already placed their order and they've paid money, while after 2 weeks you may not be knowing the exact demand. So that would be a forecast. And the demand, okay, now the demand may be fungible or non-fungible. So fungible meaning when the demand of different materials is interchangeable, and non-fungible is when it is non-interchangeable. So for example, interchangeable, non-interchangeable meaning, for example, let's say for a particular brand of mobile phone, for the same let's say 64 64 GB or 128 GB, whatever it is. You might be having the same mobile, exactly the same phone, two or three models, but they have different colors. But they are of different colors. So many customers may not be very color specific. So in that case, we call those products as fungible, because the demands are interchangeable. Now, let's say you are building a multi-item inventory model. That is, in your optimization model, you have multiple items. So the question is, do we need to run separate models for each item or a combined models? So the answer is, if there is, it depends on whether there is any interaction between the two different items. That is, if the items are competing for any limit and any common resource, for example, storage space or the total budget available, then we need to ensure that we run them in the same model. Else, we can run different models. So apart from demand, there could be we could also have inventory targets in the form of, we could also have inventory targets. Inventory target is basically how much inventory we want to keep at a particular stage, at a particular stage in the supply chain, or a particular warehouse. And this could be in the form of minimum, maximum, or target. And inventory targets could be measured in terms of units, or days of inventory, or weeks of inventory. Again, for this days of inventory, weeks of inventory, there are formula, but I'll not go into that. Okay, now coming to customer service level. So customer service level is a measure of how much percentage of the customer demand we can meet with the available inventory. That is, it is the probability of percentage of not having a stock out during a given period. So, and this is this graph. So this graph is it represents how customer service level varies with the amount of inventory. So this is highly non-linear. So you might be able to meet 80% service level with just 10 units of inventory, but if you want to meet 90% service level, you might need to have 20 units of inventory, and to meet 99% service level, you might need 50 units of inventory. So it's highly non-linear. And for retail industry, the average level is 90% average customer service level. And for high demand items, it would be 95% service level. Now, how to set the inventory service level targets? Okay. So all of you know about supply and demand. So these numbers shows how service levels will vary based on supply reliability or predictability, and demand predictability. So the higher the reliability, I mean, so on one hand you have the cost, low cost and high cost, and on the other hand you have risk, which could be categorized as low risk and high risk. So for high risk, high cost items, you might need to go for low service levels, because you do not want to keep too much inventory. While for low cost, low risk items, you might want to go for very high service levels, for example, 99%. And for high cost, low risk, or low cost, high risk profiles, you might need to go for intermediate service level, that is around 90%. Okay, any questions so far? Okay. Okay, so let me quickly go to this one before I go to this. Okay. So, in factories, what often happens is, whenever there is less production, sorry, less demand, we can either go for a slowdown or shutdown. So slowdown is when you are gradually stopping, you are gradually reducing your production. And shutdown is when there is no production at all. So what you and this graph what I've shown you, this is something which I uploaded, so it's not very accurate. So on the x-axis you have time, and on the y-axis you have the production level. And as you see, y as you see as we move up, I mean with as with time we are decreasing, we are gradually reducing the quantity of production. So we are doing a slowdown, and then at time at a certain and then there is a complete shutdown from this point to this point. There is zero production, and then once we resume gradually resume production, it follows a certain slope. And then we gradually start production in full scale. Now, can anyone tell me why we need to go for this gradual slowdown? Why we can't directly move from this level to zero production? And on the other hand, why when we are starting, when we are resuming production, why we are gradually moving from zero to the normal level of production? Why we cannot do that within a particular day? Anyone can answer that? Okay, yeah. So the answer is in factories, the machines which we operate, they are, it's not like you're switching on or off your computer. So once you stop production, first of all, there would always be some inventory sitting at every operation. So we need to ensure that that inventory gradually moves out of the system. So we need to slow down production. And secondly, the machines also cannot suddenly start or connect or shut down. So we need to give them some time. So that's why we have to gradually slow down our production or gradually ramp up our production. And what happens is sometimes we can use optimization to understand when we should be going for a shutdown or slowdown, or for how many days we should be going, or I mean, how many days shutdown we should be doing. Should it be like a 7 days shutdown or a 14 days shutdown? Because what happens is, if your demand is low and you're operating the factory at 10% capacity, then you are still incurring some cost on operating on, because some people still need to come to the factory. Your electricity would still be running. So those fixed costs, and there would be some fixed cost of operating the machine, so those costs would still be there. So it's instead better that you if but when there's a complete shutdown, then you don't incur those additional fixed costs. So in those situations it is better that you go for a complete shutdown instead of running the factory at a very low capacity for certain days. And also during this shutdown you can perform other planned activities, like any sometimes some of the machines that you operate in the factory need to be maintained, or need to go through some maintenance activity or some upgradation. So those activities can also be performed. Okay. Sorry. Okay. Now, in supply chain, we can have two kinds of problems. One is the simplest form, which you call as single echelon, echelon meaning layer, and multi-echelon meaning multiple layers. So single echelon is when you are, let's say, you are directly buying from the supplier. I mean, the customer is directly buying from the supplier. So that is what we call as single echelon. So there would be certain lead time from the supplier to the distribution center, from where the customer is purchasing. Whereas in multi-echelon, there might be multiple layers. So there might be a uh, fulfillment center. There might be multiple distribution centers, and these distribution centers might have different lead times. So that's what we call as multi-echelon. So in the next class, or probably in the next offline class, we will look at one of the multi-echelon inventory optimization problems, and we'll see how we can formulate that problem. Now, these are some of the stakeholders in a multi-echelon inventory optimization, sorry, in a multi-echelon supply chain problem. So we might have large enterprise OEM. Anyone knows what is OEM? Anyone? Okay. So OEM is original equipment manufacturers. So there are some, and again, you can read up on what is original equipment manufacturer. And apart from that, you might have wholesalers, logistics providers. So your trucks or your vehicles which will carry your materials, the contract manufacturers. Sometimes, so these will be of much smaller quantity, so sometimes you do not want to manufacture everything in house because of the cost factor, or you may not have that much capacity to manufacture, and you do not want to set up a new factory just for manufacturing a certain material, certain product. So you outsource that to contract manufacturers who would do it at much lower cost. And then you have stores or dealers, distribution centers, and also your raw material suppliers. So these are some of the typical partners in a multi-echelon problem. Okay, now in one of the previous slides we are discussing about discrete manufacturing versus continuous manufacturing. So in discrete manufacturing, we have something called bill of material. So bill of material is is a list of raw materials and different other components, subcomponents, and parts which are required to manufacture an end product. So if we look at a bicycle has different component parts, for example, wheel, seat, handlebar, and frame, and which can again be broken down further. So, for example, a wheel would consist of rim and a tire. Now, an important point to notice is besides the component parts, this bill of material also contains the number of units that you need. For example, in a bicycle, you would need two wheels, and then because you need two wheels, you need two rims and two tires. So this is the information that is contained in the bill of material. So in a bill of material would contain the BOM levels. The BOM level is, so this is, for example, level 1, and this is level 2. The part name and number, procurement type, unit of measure, so whether it is in units or whether it is in kilograms, then how many units. So in this case, the units are either one or two, and a description. So that's the information which a bill of material consists of. Okay, now sometimes there could be some supplier constraints when we are in a supply chain. So much of the processes, sometimes many of the processes are outsourced to suppliers. So, for example, let's say a semiconductor company would be outsourcing some of its stages to suppliers. So it might be saying that I need material. It would be requiring material M2 from supplier A and B, but it needs 30%, minimum 30% from supplier A and minimum 40% from supplier B. Okay, now can anyone tell me why we have this? Why a company would be having this kind of rule that I would be requiring minimum 30% from supplier A and minimum 40% from supplier B? Because, okay, anyone can tell me?
So maybe
Hmm.
sometimes supplier A wouldn't have the products needed, and then supplier B would have it needed. We could then
Hmm.
take more products maybe.
Yeah, so it's basically, yeah, you're right. So it's basically to diversify. So to avoid any let's say if it takes everything from supplier A, then in case supplier A is not able to send, then everything is gone, right? So that's why to diversify it, they take from different suppliers. Any other answer? Any other option? I mean, that is one answer. Anything else?
Maybe the quality of the material.
Okay. Okay. Anything else? Okay. Yeah. No. I mean, in this case, we're assuming that the quality of material is the same for both suppliers, And another answer you could have given is the maybe they are charging different costs. But again, in this case, we'll assume that the costs are also same. So yeah, so basically to diversify, they generally they would be procuring from different suppliers. And yeah, and again, it's not necessary that, and sometimes these suppliers in turn buy from another supplier. So just wanted to show that. Um, yeah, and apart from minimum constraint, there could be also maximum or target constraints. And these constraints are typically applied on the last leg, that is suppliers A and B in this case. So, so let's say I'm talking about Intel, and Intel is buying from supplier A and B. So, does Intel need to bother about supplier X and Y? Anyone? Okay.
It does not.
Yeah. And okay, so now let's ask you a formulation question. So, so the constraints could be minimum 30 plus minimum constraint or maximum or target constraint. So, how would you write this constraint? So, let's say the material that you require is represented by X. The material at sorry, I lost this one. The material that you require here is X. So, what would be the constraint that you would be writing? If it's minimum 30% and maximum 40, sorry, minimum 30%, minimum 40%. Anyone? Okay. So if it's minimum or maximum, you'd be writing, if it's minimum, you'd be writing less than equal to constraint. And if it's maximum, you'd be writing greater than equal to constraint. And target, you'd be writing slack surplus. But this min max could also be, so the supply constraints are typically not very hard constraints, are typically soft constraints. So they have much lesser priority than other constraints like meeting demand or minimizing cost, minimizing inventory holding cost. These are much lower targets. So they could have, you can put a lower priority in the objective function. Okay, and how would a typical model output look like? So this is just I took the screenshot from some website. So for you would have for every time period. So let's say I'm running the model for 10 days. Then for every day, you will have for different facilities or different locations for different products. What is the inflow? What is the initial storage and what is the final storage? Meaning initial storage meaning how much inventory I was carrying at the beginning of the day, and what is the inventory at the end of the day. Okay, I don't know what is percentage and total carrying cost for this row. So this is for every product. So this is information or the model output at a product level. Um, so for every product and for every location where the product is stored, I have the total inventory holding cost and the initial inventory and the final inventory, and how much inventory flowed in on that day. And if I want to see the metrics by demand, then for every customer, I would have so different customers would be having different product requirements, and for different days, I have the minimum and maximum demand and how much was satisfied. So again, these are the typical metrics. These are some of the metrics that we show to the customer when we are building this kind of an inventory optimization model. That is how much in terms of demand fulfillment and in terms of product inventory holding cost. Okay, so these are formulation things. So we'll come to this later. Now going back here. Okay, so in the last class, I think we discussed about lead time. So lead time is for manufacturing, it would be the time to produce something, and for produce a material, and for if you're procuring, then the time between your placement of the order and you're placing the order and the time when you receive the product. And this lead time may be deterministic or stochastic again. And it could, the lead time could be in days. It could be, I mean, again, for manufacturing process, it could be in it could be in seconds, it could be in minutes, it could be in hours. For transportation process, it would typically be at least hours, between hours to days. um, Apart from lead time, some of the other constraints that could exist in a, manufacturing or supply chain problem would be manufacturing yield, capacity, batching constraint, supplier constraint, and inventory target. So supplier constraint we have already looked at. Now we'll look at the other constraints one by one. So first, coming to batching. So batching is when you need to use a specified number of products and not more or less. I mean, it could be more or less, but on one side only. So for example, minimum batch size, maximum batch size, batch multiple, these could be some of the metrics in batch size in batching. Or and batching is also, I mean, batch size is also referred to sometimes as lot size. So, can anyone explain to me what is minimum batch size, maximum batch size, batch multiple? Just based on the the English, just based on the words in the words here. Anyone?
So we should define kind of a number, and then minimum batch size would be that uh, our batch should always consist of things which are lesser than that number, and maximum would be, oh sorry, minimum would be the other way around. Maximum would be upper bound, and batch size multiple would be should be equal to that.
Yeah. So let's say minimum batch size is 20. That means, what you said is right. So minimum batch size is 20. Then if I can produce either 0 or 20, I mean 0 or greater than equal to 20, but it cannot be anything between 0 and 19. I mean 0 and 20. Um, and batch maximum batch size and batch multiple, as you said, is yeah, if it's like 5, then it has to be either 0 or 5 or 10 or 15. So could I have a combination of minimum batch size and batch multiple, or I can have only one of them? Anyone? Okay. Yeah, I could have a combination of both. So minimum. So if my minimum batch size is 20 and batch multiple is 5, then I could be having my production can be either 0 or greater than equal to 20. So it could be either 0 or 20, 25, 30, 35, and so on. And maximum batch size is what is the maximum uh, size of a batch. So you cannot exceed that size. So let's say even if so if let's say if my batch size is 20, then in one batch you cannot have more than, you cannot process more than 20 units of that product. And batching is one variable, one constraint which requires integer variables. So we'll see in the next class how to formulate that. Now, coming to capacity, there could be multiple types of capacity in any manufacturing or transportation problem, any supply chain problem. So if you're talking about production capacity in the factory, then it could be either the machine or tool capacity, and it could be manpower capacity, that is the available number of available manpower into working hours per person, um, or it could be the storage capacity at the warehouses. And if we are purchasing from a supplier, then it could be the quantity that the supplier, maximum quantity that the supplier can send. And if it is transportation capacity, then so let's say we are manufacturing in our factories and we are sending it to our fulfillment centers or or to our distributors, then it could be how many vehicles are available and what is the capacity of the available vehicles. And sometimes what happens is if you have less vehicles, then you will not buy a new vehicle. If I mean suddenly, let's say during the big billion days sell, the demand increases, so only for those 5 days in the year you will not be procuring new vehicles or hiring new vehicles, so you'll be taking some vehicles on contract so that you're able to service that additional demand for those few days. So in this kind of problem, you will be taking decisions around how many vehicles to use, what size of vehicles to use, as different vehicles may have different cost, speed, and capacity. Okay, now coming to yield. So yield is a measure of the efficiency of a process. So yield could be, not could be, but yield would vary between 0 and 1. So one is, when everything that goes in into a process comes out, there is no scrap product or wasted or defective product, and 0 means there is nothing which comes out. So typically it varies in that 0, so yield would be in that 0.8, 0.9 range. um, and obviously the better the yield, the higher the yield, the better it is. Okay, so I'll not go through all this, but essentially what happens is after we inspect that there is some issue, sometimes products go for rework, and even after rework, sometimes it still turns out to be defective. Then we scrap that product. And yield is again measured as items out by items in. Okay, now coming to changeover time. So changeover time is another very important concept in manufacturing. So changeover is also referred to as conversion. So changeover is after so sometimes the same assembly line, the same manufacturing line is used for producing multiple products. Now let me give you a practical example. So let's say you are for example, let's talk about toothpaste. In toothpaste you have different varieties of products, varieties of flavors these days. So let's say you have, I don't know, uh, Colgate Max Fresh, then you have Mint. So let's say on the same manufacturing line, you are producing Colgate Max Fresh. Then after that, you need to produce Mint on the same assembly line, on the same manufacturing line, which we call as assembly line. So after you manufacture Max Fresh, since the components are different, after you manufacture Max Fresh, you need to clean up the line so that there is no leftover part, because otherwise if there is a leftover part, it will contaminate the next product, because next product is something different. So we need some time to clean the assembly line, make sure that there is nothing left over. And also what happens is sometimes you need to these machines today so these days all the machines that you have in factories are highly automated, so you need to change some configuration, etc., on the machines by it's all computerized, so you need to change some configuration, so those things take some time. So whenever you switch from one product to another product on the same assembly line, you need to spend some time on in converting the line from the previous product to the next product, so that the line is ready for manufacturing the next product. So this is what we call as, and sometimes it might happen that some certain products need, when certain products manufactured, the line gets heated up, so you need to cool down the line before you go to the next product and all those things. So that the time spent in converting a assembly line from one product to another product is referred to as changeover time. And this is very important concept, because this changeover time is basically a waste of time, because this time in this during this time you cannot manufacture anything on your line, right? So the lesser the number of changeovers that you need to do in a day, and the better it is, the more time you are making available for actual production. um, yeah. So but the problem is, in today's world, changeovers have become very significant, because when we look at any product, we have a lot of flavors, a lot of varieties or options available than it was, let's say, 20 years back. So if you are, let's say, even if you're talking of any food product, let's say cornflakes. So in cornflakes, Earlier there was only one variety, but today you have like 10 different varieties of the same company. And the same I mean, one is 10 different varieties of flavors. Then you have 10 different kinds of 5 different kinds of packaging. You have 100 gram, 200 gram, 500 gram. So they will require different kinds of packaging. So the demand is I mean, and whatever demand you have of cornflakes for, let's say if you're talking about Kellogg's cornflakes, then that demand is getting spread across all these 50 different combinations of products and product flavors and sizes. So the demand for each flavor, I mean each variety. So let's, for these 50 options, the demand for each of these 50 options has reduced, but the amount of number of changeovers have to be increased, because you need to you need to produce all 50 of these options every day. So number of changeovers has increased, but we cannot obviously increase the factory capacity. So with the increase with the same factory capacity, we need to ensure that we are running the assembly lines in intelligent manner, so that we are still able to do all the changeovers with the limited time and meet the customer demand. Okay. So any questions on this? Okay.
What are the benefits of having too many flavors or too many packaging sizes? And is it worth paying the price of having to have some changeovers? Because if you have like four or five things, then you could set up four or five different columns in the same factory, and you could just not have a changeover time anyway.
Right. That's a good
What is the
question.
trade?
Yeah. So the trade-off is, if you set up more lines, then you will have you need a bigger factory, right? You need to set up more lines, because the number of processes that you need for a Max Fresh toothpaste and a Mint toothpaste would remain same. So you need to set up more lines, which means in addition extra, you need to have extra space in your factory, or you need to buy more machines, and you need to buy more machines, right? So which is not a good idea. That is why
No, so
Mhm.
can we not split our factory into half and then do half of the part in the Colgate Max Fresh and half in the Mint?
Yeah, that is what is done sometimes, but it is not always. I mean, you don't have, I mean, you can probably split into half, but if you have five options instead of one option earlier, you can maybe you cannot have five x machines, right, than what it was before. You can have 2x machines. I mean, as you said, you can split half of the machines. You can have half of the machines for one flavor, half of the machines for another flavor, but you cannot have five different machines, right?
Yeah,
So
we can't.
yeah, so that is the reason. Yeah, but
So what
Mhm.
I was wondering is ki, like ultimate objective of the company was to gain profits, and that's
Mhm.
why they introduced these five or six or 10 different flavors in the first place. Because as you
Mhm.
said, initially we had only one flavor or two flavors maybe,
Mhm.
and
Mhm.
now we have 10 flavors.
Mhm.
But if we had one or two flavors, then in the factory we could set up half of the like splitting into half, and we should not have any changeover time. But now we have to have a changeover time because there are too many. So
Yeah.
what is the trade-off in between? Is like profit greatly exponentially increasing, or what is it?
Yeah, so the reason why the company introduced the flavors is not, I mean, it does not do so keeping in, for reducing changeovers. When the company adds it does not keep that in mind. What it keeps in mind is the customer preference. So customers want different options these days. So, and it's not just different options, but newer options. So that's why they have to come up with different varieties or different flavors. uh, and how we handle that in operationally in the factory, that is a secondary question then. So the main question is, how do we increase the sales of, if I keep eating the same thing, the same old cornflakes every day, I'll get bored. So they'll have to introduce other things like whatever choco chips and all that. So and that also helps to increase your market share and get newer customers into your portfolio, like, and different products have different target customers. For example, if it's some chocolate cornflakes,
Yeah,
then
that's true.
maybe it'll be more targeted at children. So So the how we handle changeovers in factory, that is a very secondary question to the company. The main question is how do we increase our visibility or footprint in the market. Yeah, but good question. Okay, did that answer your question?
Yes, certainly.
Okay, any other question? Okay. um yeah, so the impact of changeover time is a long changeover time. And okay, and coming to the time required, so this time required, probably I should have add all those details later, but the time required for changeover can vary. Again, it depends on the industry, but it can vary from, let's say, 15-20 minutes, sometimes even an hour, depending on what product to what product we are switching. So it's not like 2-3 minutes, then it's probably okay. But if since it takes sometimes it can take half an hour or 1 hour, it is a pretty significant time. Okay. And what is the impact of change over time? So this will reduce production rate, increase lead time. So in lead time, meaning in this case, what I mean by lead time is the time. So let's say I am first producing Max Fresh, and then I'm producing a mint toothpaste. Then the time difference between the time interval between the last unit of Fresh and the first unit of mint production, that is what I'm calling as lead time, basically. So your lead time includes the waiting time, I mean not waiting time, but changeover time also. And increase whip stock. Uh, okay, and it will increase material and time waste and increase the cost. Okay, so now what are some of the steps in, and again, some of my slides are quite haphazard. It's not in very sequential order, but yeah. So what are some of the steps in supply chains? What are some of the things we do in supply chain rather? So one is we can be procuring, that is buying from a supplier. We could be manufacturing in the factory, transporting through our logistics providers, warehousing or storing, and also we could be doing QA, QC or testing. All of you know what is QA, QC, right? The full form of QA, QC. Anyone?
QC is quality control, but not sure about.
Yeah, QA is quality assurance. Okay. Now coming to manpower, there are there could be some manpower related constraints. Manpower as in human, wherever human workforce is required. So one is manpower availability. So how many people are available? Working hours per person per shift. So typically, in factories they have two shifts. Again, some factories have three shifts. So if it's a 12-hour shift, working hours could be 10.5, because there would be some time for lunch break, restroom break, etc. And the time required to complete one unit of work by one person, and the skill level of different people in different jobs. So some people might be more skilled for a particular job, less skilled for another job, and so on. So these are some of the factors we need to keep in mind while building any model related to manpower optimization. So we'll look at a manpower optimization from problem formulation later on, but I just wanted to give you the background here. um, Okay, so in any kind of supply chain problem, there are the activities could be divided into three categories: value added, non-value added, and non-value added essential, and non-value added non-essential. So non-essential we should try to eliminate, essential which we should try to minimize, and non-value added activities could be things like inventory, waiting time, and rework or scrap. So how can you reduce the inventory waiting time? Anyone? So inventory waiting time, what I mean by inventory waiting time is I have inventory, but it is not getting processed by the machine because the machine is already processing the previous batch. So what could be done to reduce the inventory waiting time? Okay. Yeah. So what we could do to reduce the inventory waiting time is we could see if there is uh, we could speed up the downstream operations, that is reduce the reduce the lead time of the downstream operations, or we could add more machines downstream so that but again, as we discussed, so adding machines is not always a feasible option, but we could see that if it is possible to add more machines downstream. So these are, so and again, how to reduce inventory waiting time, that is a part of simulation or queuing theory. So that queuing theory part will come to later on, but just wanted to give you some very brief idea. So these things will come to later. Now, what we there's something called upstream or downstream. So upstream is basically the process. So if there are multiple processes, the process, let's say A and B are two consecutive processes, then A is the upstream of B and B is the downstream of A. And what is source and sink? So source is the first upstream, first operation in the chain, and which has no further upstream, and sink is the last operation in the chain which has no further downstream. So these are some common terminologies we use in manufacturing. And parallel or sequential, I think all of you know. So parallel is whenever you have multiple we have some operations happening parallelly, then it would be parallel. And let's say in manufacturing, if you have parallel operations, we could be either increase. Okay, so that will come to. Okay. Um, Okay, and this day or night shift, I think we discussed already. So day or night shift is, again, there could be multiple shifts in a factory. Some factories have three shifts, some factories have two shifts. And what happens is we need to ensure that all the available people are scheduled in those shifts after complying all the government regulations. So there are certain regulations, like, for example, one person cannot work for more than 5 days a week. One person cannot work for more than X hours in a day. And we need to, in any organization, needs to ensure that all those government regulations are adhered to while allocating the people, allocating those headcount, the people in the shifts that we have, and that is what we call as shift scheduling. Okay, I think we will stop here. And just wanted to check one thing. So Monday I might be, I'm not sure if I'll be able to conduct the class, online class in the same time. How about Tuesday? Tuesday is. Do you have any free? Do you have any slot in which you're available? All of you are available, guys. Any slot in which you're available? Okay, someone needs to tell me something. Okay. Anyone can tell me which slot you're available on Monday? Sorry, not Monday, Tuesday. or in any other day in the next week?
Hello, sir.
Yeah, yeah. Tell me.
Sir, what about Wednesday?
Wednesday, what time?
Uh, Maybe 2 to 3:15. That slot.
2 to 3:15 is a bit difficult. Okay, Monday, how about 10:30 to 11:45? I see that is available,
So
but
we
is
have a
it?
class. We have a
Yeah.
class at that time.
Okay. No, Monday, Tuesday, Wednesday is a bit difficult. Wednesday 2 to 3:15. Okay, no, that is a bit difficult. How about Thursday?
Yeah, third Thursday also like 2 to 3:15 seems fine.
Actually, Wednesday and Thursday afternoon time is a bit difficult.
Then what about like Tuesday 10:30 to 11:45?
That is fine. That works for me.
Like one course is there. I don't know anybody in our class is taking that course. Like LPC or like if nobody is taking, we can take that course like 10:30 to 11:45. That
Yeah,
slot.
I'm good with that. So Tuesday 10:30. Everyone is okay with that time, 10:30 to 11:45. Yes, no. Yes, no, guys. And regarding the next offline class, when can we have that? Okay, maybe we can discuss it in the next class. Okay, so maybe I'll, in case I'm not able to take the class on Monday, then we'll have it on Tuesday, 10:30 to 11:45. Yeah, and then at that time we can discuss about the next offline class. Okay, thanks everyone. Thanks for your time. Have a great weekend.
Thank you, sir.
Yeah, thank you.